Good afternoon. My name is Amira El-Haj Musa with ESAC Patel Memorial Institute. Thank you for joining this webinar titled Clinical Quality Language CQL Basics. Today's session will be presented by Bryn Rhodes with ESAC Incorporated. Slides for this presentation will be posted on the eCQI Resource Center. Today's meeting is being recorded. Please remember to mute your lines if you are not speaking, and do not put your phone on hold. If you must take another call, please hang up and call back in after you've completed your other call. Also, one other tip, please maximize your screens for better viewing if you can. If you have questions, please type them into the Q&A box into the WebEx screen. At the end of this session, a feedback form will appear. Please take a few minutes to tell us how we did. We appreciate your feedback. And with that, I'd like to turn this presentation over to Jennifer Harris from CMS to give a brief introduction. Thank you.
Functionality of CQL. Next slide, please. So this is one of the ways we represent the evolution of the current standards using and creating the electronic specifications for eCQM. On the left is the Health Quality Measure Format, HQMF, which is the basic electronic specification for the measure. The Quality Data Model, QDM, provides information to help finalize the HQMF and is divided into two parts, the data model and the logic. Now that we're moving to CQL, the HQMF will continue to provide the metadata and population structure, and the Quality Data Model will still provide the data model, but CQL will represent the logic used in the HQMF. Next slide, please. This is a general timeline that CMS, stakeholders, and contractors are looking at. I want to emphasize the importance of the work effort that is going on now through 2017. During this time, we will be creating measures with CQL and expanding testing and development of this standard. Looking at the box under the arrow that says Testing CQL QDM-HQMF 2.1. These are all the people, tools, and information that we are engaging with to do this testing so that we can make sure that this standard accurately represents the measure and so that we gain feedback from stakeholders. The box that says Fall 2017 Plus means that we will be implementing the CQL in the eCQMs after fall of 2017. It is also open-ended to ensure that this standard works for our eCQMs effectively and passes all testing before being implemented into the programs. As a part of the education and outreach about CQL, we want to engage you all about this standard as we continue to incorporate this standard in the measures. Thank you, and now I will pass it back to Bryn to continue the presentation and provide a more in-depth review.
Thank you, Amira and Jennifer. All right, so we'll be covering today kind of a CQL language tour. I want to focus specifically on aspects of the language. It's introductory material, but it's intended to provide a broad introduction and give you an overview of all the functionality that's available. Make sure that all the functionality is present. All right, so the clinical quality language is an HL7 standard designed to enable point-to-point sharing of executable clinical knowledge. But it also provides a clinically focused, author-friendly, human-readable language. Currently draft standard for trial use. It's available at the link provided there. That's freely available. So I encourage you, if you have not already done so, to check that out. It has multiple targets for audience, and so one of those targets is authors. Another is developers, and so those are focused on different potential users of the language. And can give different perspectives. All right, so we'll start with the general problem of accessing clinical data. So when we talk about clinical data, from the context of trying to write an expression or an artifact that would access that clinical data, we talk about it as made up of statements. So say things like patient had a routine checkup, patient was administered an antibiotic. These are clinical statements that would typically be made by providers. And they're rendered in different ways in different systems, but at a conceptual level, they all can be represented using this kind of model of a statement. So we break those statements down into different types of statements. So we say when we're talking about an encounter between a patient and a provider, that's a certain kind of statement. The patient was administered an antibiotic, and we break down the overall groups of different kinds of statements into these different categories. We label them types. From there, we can go further and use terminologies. So we can talk about codes from code systems. We can say that within the broader category of encounter statements, we can say specific types of things by saying a routine checkup is coded by the SNOMED CT code 185349003, and so on. So we can provide within the broader structure of an encounter more specific descriptions about exactly what kind of thing took place. So we get some economy of structure about describing the elements involved in an encounter, but then we still get to assign specific meanings using these terminologies. And this pattern is ubiquitous in clinical data. Almost all clinical data has some form of terminology that's associated with it to allow meaning to be given. And this also gives us a way to talk about meaning across different structures. So this is the area, and this is the pattern where we focus on writing the clinical structures. It gives us a way to talk about things in a very conceptual level. So then from there, we take the codes describing different kinds of things, and we group those into value sets. And that allows us to talk about different classes of those kinds of things. So we can say an encounter inpatient would include all the different types of encounters that we would generally think of as inpatient encounters. And we can group those value sets into different things that then allow us to talk about those concepts in different groupings and in different ways. And this pattern forms the basis of how we retrieve information, how we talk about data within CQL. So CQL has this basic notion of a retrieve. It's kind of the root expression within the language. It uses these brackets, and then it has two parts, the type and the value set. So the type is the broader class of statement that we're talking about. And then we use a colon to differentiate and indicate the value set. So in this case, we're saying I want all the encounters that were performed where their code matches the inpatient value set. So I've got an example data set here. If we think of all of these 4 records as encounters in the entire database, then only the highlighted records would be returned by this retrieve because they're the only ones that match the inpatient value set. So it's kind of a visual representation of what the retrieve is doing and what that actually means. So for each of the data types involved in any given model, there's a way to filter based on this value set. And so this pattern of encounter performed, inpatient, or laboratory test, CD4+, those are all following the same structure, using that same pattern of organizing the data into statements, statements into types, and types into kinds of statements using value sets. So from there, CQL allows you to write queries, kind of the basic mechanism for filtering this data once you have retrieved something from a retrieve. And to do this, you introduce an alias, encounter in this case, and then you can reference elements of the records that came back in the query using that name, that alias that you've introduced. So in this case, we say where encounter.relevant period is during measurement period. And if we look again at the set of records that were returned from the retrieve initially, only the highlighted ones are returned, because they're the only ones that return true for that criteria of relevant period during measurement period, so the 2015 year in this case. So the next type of statement you can introduce within a query are relationships. So I can establish relationships between the data in my query and other related information. And I provide a relationship. I describe how I want that to be filtered. So in this case, I'm saying I want encounters inpatient that also have an associated laboratory test performed for a streptococcus test, such that that result date occurred during the relevant period for the encounter. So in this case, looking at again at that set returned from encounter inpatient, only the October encounter is returned, because it's the only one that has a lab test resulted during that encounter. So I can also say without, and this example just inverts the previous one. So I can say I want encounters that did not have a lab test for streptococcus resulted during the encounter. So that would return all the encounters except the one that had that. So I can also shape the results, meaning I can change what elements I want to return. So in this case, I'm selecting only the relevant period element. This is useful for calculations where I may want to do subsequent calculations on only the relevant period from that set. So I can use a return clause and describe exactly what contents I want returned within the result. So that lets me, within the braces there in the return clause, I'm able to provide effectively an eval expression and name it appropriately. So I can do calculations in there. I can return contents of the current element. All of those types of expressions that are available throughout CQL are available within that return. So I can also use a sort by to order the results. So if I say order by start of relevant period in this case, I'm telling it I want it to order by this attribute here. So in this case, I'd return 1 first, 3 second, and 2 third. That gives me a way to order. I can also say by descending if I want to order them in reverse order. And I can order by any of the elements of the query. So the next construct to talk about is the naming of expressions. So I can define, can use identifiers to describe and give meaningful names to expressions. This allows me to reuse that expression then in further expressions. So I'm saying sorted encounters means all the encounters performed that were inpatient sorted by the start of relevant period. So then that identifier sorted encounters is available within the library to be used in subsequent expressions. So it gives me the same result, and then I can use it, for example, to pick items from that set. So I can say first sorted encounters, and that will just give me the first row in that result. I can say last sorted encounters. So because encounters is ordered by the start of the relevant period, first returns the oldest, and last returns the most recent. So note about that, if you don't specify a sort, then you can't rely on the order, because the underlying system may return the data to you in any order. So if it's important to the logic, you're picking the most recent encounter, for example, then you need to make sure that a sort is included in the query to make sure that that's part of what you're expressing. Another way you can pick items from a list is using the indexer. So you take any expression and you put brackets after it. And as long as it's a list, it will return the index item in that list. So in this case, the first item is index 0. CQL indexes are 0-based. So sorted encounter 0 is effectively equivalent to first sorted encounter. And then the second one is sorted encounters 1. All right, within CQL, we can represent strings. Often we need to express just, when describing comparisons, we're comparing against some value of a string. So within CQL, we use single quotes to delineate strings. So you can escape characters within the strings using industry standard escape. You use a backslash, as indicated there on the O'Malley. If you need a single quote within your string, you use a backslash to do it. String comparison, supported for all the comparison operators, has the semantics you'd expect. It's case sensitive, and it's based on the Unicode value of the characters. So we're not doing code pages or anything like that. It's just based on the Unicode value. In the general case, that's going to give you the expected behavior, at least when you're dealing with the Latin alphabet. So in addition to strings, we support obviously numbers and calculations. They're an important part of being able to describe the logic involved. It involves performing calculations, performing comparisons against the results of those calculations. So we support integers, meaning whole numbers, and we support decimals. So in calculations and comparisons, decimals are going to be implicitly converted when necessary. So if you compare 5 and 5.0, it will work. It'll just implicitly convert the 5 to a 5.0. So that way you can do addition between integers and decimals and just deal with them as you normally would expect. Just know that you're going to get a decimal back if there's a decimal involved. And that's true for division, addition, subtraction, multiplication. What that means then is that integer division in CQL will always return a decimal. So if you actually need to perform integer division, we have a separate operator for that called div, and then mod returns the remainder. It also uses standard mathematical operator precedence. So if you need to force precedence, use parentheses to do that. And comparison of decimals ignores precision. So that's kind of an important one. That's generally the intuitive expected behavior, but some systems will explicitly require decimal precision to be the same before they allow the comparison. So continuing on with numbers, we support rounding and exponents. So we have operators for rounding include the basic round, which you can invoke at any level of precision. We also support a truncate, which just returns the integer component. Ignoring sign, it just returns the integer component. Floor and ceiling return the greatest integer less than and the least integer greater than, respectively. So there's examples there that illustrate that behavior. So if you floor negative 5.5, you're going to get negative 6. So we're moving down the number line. Ceiling is moving up. CQL supports exponents and roots with the caret operator. So to square something, 5 caret 2. To take the square root, 25 caret 0.5. We also support logarithms, natural logarithms, and the exponent operator. So those are useful in statistical analysis, and those have come up in some of the examples already. All right, so building on numbers then, we support quantities. So quantities in CQL are any number followed by a eCQM unit. A eCQM unit is expressed as a string. So we say 25 milligrams, 100 square centimeters. 1 meter equals 100 centimeters. And 10 centimeters times 10 centimeters is 100 centimeters squared. So note that, so we support comparison and arithmetic operators for quantities. So you can compare them and you can perform basic arithmetic with them. And implementations are required to respect units, but not necessarily conversions between units. So this 1 meter equals 100 centimeters, that may actually result in a runtime error if the implementing system doesn't support conversion between units. The arithmetic operators in particular have to return quantities with appropriate units, but they're not required to support the conversion. So just be aware. All right, so we also support date, time, and time, obviously an important part of being able to express clinical logic. This is a standard format, and so within CQL we use an @ symbol followed by a standard date-time format as described by an ISO standard. And it supports integers for year, month, day, hour, minute, second, and millisecond, and we have a time zone. So it's a point in time on the Western calendar. CQL also has a time, which is an @ followed by a T, and then the same format. So a date is just the year, month, day. The date time is the year, month, day, followed by a T and the hour, minute, second. And if you just want a time, then you say @T with the time format. So we also support the time zone. If you don't specify a time zone, it's assumed based on the evaluation context. So that's an important aspect. We also support partial date, time, and time values, but only for trailing precisions. So if you specify a day, you have to also specify a year and month. That's just implicit in the way that the literal is built here, and the way that the expression is written. But just making that explicit. So I can say just any date in the year 2014 using @2014. Or I can say any day in the month of January 2014 using that. So we also support building date, times, and times using expressions. So if you have an expression where you need to construct a date, time, or a time using elements from different places, you can do that using those operators. We also support extraction. So if you need just the date or just the time or a specific component, so you can say year, month, day, you can pull those out. And we also support accessing the current day by saying now for the date time, today for the current date only, and the time of day for the current time. So we support date comparison using all the standard operators. We can also perform precision-based comparisons using same as. So I can say, is January 15th, 2014 the same year as February 15th, 2014? And the answer is yes. So those ones are important for when you're performing comparisons on partial daytime values. So I can decide at which point in the date time I want to perform the comparison. I can also use same year or before for a relative comparison at a level of precision. We also support date arithmetic. So time-valued quantities with the name of the precision as the unit. We also support the eCQM units. So you can say 1 day, or you can say 1 string D. And those will both result in a time-valued quantity of 1 day. And then those durations can be added to or subtracted from date, time, and time values with the expected semantics for durations with variable days, such as years and months. right? So if I add 24 months to 2014, I'm going to get 2016. So it works with partials, it works with date times, and it works with times. All right, we also support computing the duration between and the difference between. The duration between returns the number of whole periods between two datetime or time values. So the number of whole months between those two is 0, because there aren't enough amount of time for there to be an actual month there. But the difference between determines the number of boundaries crossed between those two datetime and time values. So in this case, we return 1 because there was 1 month boundary crossed between January 31st, 2014 and February 1st, 2014. Even though there's not a whole month, there was 1 month crossed. There are two different ways of computing the space between two date times, and those both have use cases within clinical quality logic. We also support intervals as a first-class element. So you use this interval keyword to introduce an interval. Support standard mathematical notation to describe those intervals, so open and close using brackets or parentheses, respectively. And then once you have an interval, you can test for membership using contains and in, and you can determine the boundaries using start of and end of. And you can also ask for the width of the interval. So an interval contains all of the points within the boundaries. So this interval 3, 5, for example, contains the points 3 and 4, but not 5 because that's an exclusive boundary. This interval contains all of the decimals greater than or equal to 3.0 and less than 5.0. So in comparing intervals, then, we have a set of operators that allow you to describe the relationships between two intervals. So if I have two intervals, I can put them into a relationship using one of these operators. If it's before, meaning it happened completely before this event, then it occurs that way. There's a meets before, which says that this is immediately before. The end of the first interval is immediately before the start of the second. And then overlaps includes, meaning that this first interval includes the entire second interval. Starts, ends, same as. So we have a full suite of operators that allow you to describe every possible relationship between two intervals. We also support timing phrases. This is to make it easier to express those relationships. So the before and after interval operators can add a prefix of starts or ends and a suffix of start or ends. So you can say interval X starts before start of interval Y. Right, and that's going to capture all of those relationships. I can also indicate an offset. So I can say it starts 3 days before the start, and that's going to capture 3 days before is going to capture that one. Right? And 3 days or more before is going to capture all of those. Can also introduce a within. So starts within 3 days of, and that allows me to capture that set. So anything that happened in that range. So list operations, we also have a full set of list operations. I can test for membership for items in a list using the contains and in operations. And I can compare lists using equality and the includes and included in operators. So I can say the first list includes the second list because every element in the second list is also an element in the first. We also support combining lists using the union. So union operator combines two lists. There's a specific note here about the current specification. It does not eliminate duplicates, so a distinct must be used. in CQL 1.1. However, there is a DSTU comment to change this behavior to support the more intuitive duplicate elimination semantics. So in this case, we would combine the elements from both lists with elements appearing in both lists appearing only once in the result. So the list 1, 2, 3, 4, 5, union 4, 5, 6, 7, 8 gives us 1 through 8. Also support intersection. So I can say, give me the elements from the first list that are also in the second list. And in this case, that gives me 4 and 5. And we support the except operator. So give me the elements in the first list that are not in the second list. And in this case, that gives me 1, 2, and 3. So anytime you have within CQL the result of a query, it's treated as a list. And so these list operators work on the results of queries. So I can combine, say, a set of encounters from one value set with a set of encounters from another value set using a union, or I can use an intersection to compute only the encounters that are common between them, or I can use an except to give me only the encounters that occurred in the one and not the other. All right, so that's a tour of CQL, all the functionality, and at this point we will open it up for questions.
All right, thank you. So here are some links, and again, we will be posting these slides to the eCQI Resource Center on the CQL space. So you can reach information about the DSTU here, HL7 resources, the GitHub tools repository, and also the CQL JIRA site where you can submit questions. And on the next slide, we'd like to cover the Resource Center as well. This has a lot of information specifically about all the standards and about CQL. There's a space dedicated to information that you can find out more information about that. And then here's just a screenshot of the main page. If you go to the easiest way to get to the CQL space is by going to the topic area's blue ribbon at the very top and choosing CQL. And then the next slide is the CQL space, and in the middle there we have the CQL formatting and usage wiki, which contains a lot of the information that we're gathering from these webinars and from cooking with CQL courses to formulate information for folks about conventions and usages for CQL. And then there's information about upcoming events and other resources here. So thank you, Bryn, and thank you, Jennifer, for giving the introductions earlier. I'd like to thank everyone for joining us today. We hope you enjoyed this discussion as much as we did. Look for slides again for this presentation on the Resource Center there under CQL Educational Resources. You can find the slides and some of the recordings of the previous presentations. Also, please take a few moments to complete the feedback form following the close of this webinar. And we thank everybody for joining us, and we hope you have a great day and have a great long holiday weekend. Thank you.